in service-oriented computing should consider this important issue. The service realization should not follow some specific implementation rule to be in this paradigm. But in reality, we will see the difference. Okay, let's come back to transactions. I want to explore the transaction a little bit more, especially in terms of service oriented computing, and then we see the famous transactional model in service-oriented computing. When you look at the business transactions in service-oriented computing, it's all about order and dependencies. You've seen, we have the services. Which service will be first, second, third? Which services will be parallel? And what sort of data will connect all of these services or this scenario together? We have order of these services, and then we have dependencies between these data. First, and the most important thing, we have the concept of alternative service execution inside of a transaction. The second, this is about dependency. We have data-oriented service composition, the dependencies between data that you try to define inside of a transaction. Then you have sequence of services, and you may have parallel service composition. Several services can be run concurrently in parallel. The alternative service execution will goes to alternative service composition. It's more like I say, I'm going, for example, book my travel with BA. If it doesn't work, I go for EasyJet. This is kind of alternative scenario. But what is the problem now with this order and orientation? First, let's describe this with a little bit formal definition. We use the dependency graph. It's very conventional in transactional world. The dependency graph shows the dependency between transactions. Who access what and who is the next. If I have a data item and everybody read that data item, there is no dependency between these people that share this data item. But immediately when somebody writes on this data, then there is a dependency. If I read the data and somebody else writes on top of it, there is a dependency. Because, for example, if I read a data, a bank account or a budget, and somebody else took the money from the budget, and then I go for shopping, that money is not the money that I have, in my calculator or whatever. The second one is write and read. Now, I'm accessing a data item for writing, and somebody else read this data. There is a dependency. Or write and write. This is another dependency. Anytime there is a write operation, writing on something, there is a dependency. If it was just read, everything could be fine. But what is the problem? These are the challenges. The first one, these are the classical challenges. You can make all sorts of complicated scenarios based on these. These are just very simple ones. The first one is lost update. A sub-transaction, a transaction, read the data. Somebody else come and write on top of this data. Then the first transaction, based on its calculation, write on top of that particular data. We have a lost update. It's more like, in this scenario, sub-transaction 1 done nothing. Dirty read. A sub-transaction provide the data by writing or whatever. Another transaction read that data, the example that we had a few seconds ago, and the first transaction or another transaction write on top of this data. Therefore, sub-transaction 1 in this scenario has inaccurate data or wrong data. This is dirty read. Unrepeated read. In this scenario, sub-transaction 1 read the data. Another transaction write on top of that, and when the transaction 1 wants to read it, it's not the same. That means you cannot repeat same read on one data during lifetime of a transaction. When you look at that, you will find out something interesting. Always there is a loop in dependency graph. Whenever there is a loop, there is a problem. Whenever there is a loop, you will have inconsistent data. Then one of the classical solutions of solving this problem is avoiding the loop, or making the whole system in a way that it's impossible to make a loop. Actually, this is what locking mechanism does. For example, if you lock the data with read lock, this is SX lock. They call it SX lock, means share and exclusive lock. Anytime you put S lock by reading, you can put another S lock on top of it. It's okay. But you cannot put any X lock and expect anything else. X lock is incompatible with even itself. That means if you write on something, there is no way for reading it by somebody else. And if somebody has been read by some transaction, any other transaction cannot write on top of it. Therefore, easily you can avoid the loop. But we saw in service-oriented computing, this is pretty difficult, especially in terms of long-running transaction. One of the most famous protocols for solving this problem is WS protocol, WS transaction protocol. It has 3 protocols. I start from end. WS business activities. This is for long-running transactions. This has the most complicated structure. WS atomic transactions, it's for just normal, conventional transaction. And WS coordination, it's a protocol for coordinating these transactions. WS transaction protocol has been introduced by IBM and Microsoft. It's a great model, but it has some problems. I will go through problems after introducing the next protocol, which is BTP. BTP has been introduced by Oracle and some other companies. Oracle is the main one, is the big one. BTP has 2 types of transactions, atom and cohesion. Atom, it's more like conventional transactions. It can use the conventional protocols like 2P commit protocol. Cohesion is for long-term or long-running transactions or long-life transactions, all the same. conceptually it has two structure. One is BTP superior and BTP inferior for bypassing this transaction context. Inferior normally is responsible for reporting to the superior its outcome, the context. We will see context later. And superior is the main one that determines the success or unsuccess. It finalizes the transaction. What are limitations? Theoretically, when we go to long-running transactions, we're supposed to provide at least two different methods of commitment. Because the commitment, that finalizing, the finishing the transaction is not same as the conventional one. One is BACC and the other one is BAPC. Unfortunately, service-oriented transactions support just BACC. What is the problem? The problem is they actually violate that first picture about service-oriented that I've shown you, that shows the realization level. On the other hand, there is tightly coupling between the coordinator and participants, or at least initiator. They support in terms of pattern behavior, just do compensate pattern behavior. And they have limitation for alternative scenarios. Okay, now let's look at the transaction context, and probably some of you are interested to design your own transactional system. We have transaction context that shows the structure of a transaction. This is very simple example. We have just booking a flight and booking a hotel, and it's sequential. You want to book a flight and then book a hotel, and of course they are related to each other. It has to be in the same date, and the timing is supposed to be relevant, and you may even consider some budget limitation. That's why there are limitations. The scenario is pretty simple with all of these things. First step, you can just bypass the transaction context to the first participant if you have distributed coordinator, and if you want to avoid all of those limitations on two conventional coordination framework, transaction framework. We assume that you have a coordinator in BA and you have a coordinator in your hotel system, which is Travelodge here. You send the transaction context, you get the acknowledge, you send the transaction context to the next coordinator, and then both coordinators now know what is the structure, and there is a sequence. The first one will be BA, the second one, Travelodge. The result come back to the initiator, which can be you. Generally, this is the schema of such a transaction. We have the root, and then we can start to open sub-transactions and have service composition, at least 3 different compositions: sequential, parallel, alternative. We can even delegate the whole transaction to a coordinator.